Let's learn Lebesgue theorem in this video. So here you can see the statement of the Lebesgue theorem. Okay. Here you can see the statement of Lebesgue theorem. If the function, there is a function f, okay, and they are saying this f is monotone. Where it is monotone? It is monotone on the open interval a comma b. We want to know about what is monotone. All these things, these are very basics. Okay, the definition of monotone. When you say a function f is monotone, it means there arise two cases, that is monotonic increasing and monotonic decreasing. Okay, these are the basic things. Okay, we can learn the basic things in somewhere. Okay, after some days I will post videos on that also. Okay. If the function f is monotone on the open interval a comma b, then what we have to prove is this f is differentiable almost everywhere on the same interval. Okay, open interval a comma b. This is what we have to prove. We should not have any confusions on writing the statement of this theorem. Okay, so first you have to take a function f, right? And you are saying this f is what? Monotone on where? On the interval, open interval a comma b. Okay, if f is monotone on open interval a comma b, then this f will be differentiable almost everywhere on this open interval a comma b. Differentiable almost everywhere. Okay, this is very important. So here let's pass on to the proof. We are going to prove f is differentiable almost everywhere. To prove that, what you will prove is m star of a equal to 0. That is what you will prove in the proof of this theorem. Okay, so let's start the proof of this theorem. So here you can see the proof. Okay, first you are assuming in the statement they are given you f is monotone. So I told you that if f is monotone means there arise two cases, f is monotonic increasing and monotonic decreasing. Here you are assuming f is monotonic increasing, that is f is increasing. That is why here you are writing assume f is increasing, and in the question they are given you an interval, right? Open interval a comma b, and you are saying that open interval a comma b is bounded. So these conditions you are assuming to prove this theorem. Okay, assume f is increasing and open interval a comma b is bounded. Now let you are taking a set. As I told you earlier, you are going to prove m star of a equal to 0. To prove this, you need a, right? You need what? A. So first you are defining a. Let a is equal to set of all x belongs to open interval a comma b such that upper derivative of f at x. This is how you have to read this. Upper derivative of f at x greater than lower derivative of f at x. This is how you are taking a set a equal to like this. The elements present inside this a will satisfy this condition. Here you are having x, right? And this x belongs to where? Open interval a comma b. Now you can write to prove, right? Because you defined what is a and all these things. So you are writing to prove f is differentiable almost everywhere on E. That is to prove this m star of this a equal to 0. Okay, this is our duty to do now. Okay, what is our duty? To prove m star of a equal to 0. That is what our intention to do in the further steps. So to prove this, we are defining some other thing also, that is define E alpha comma beta is equal to this. That is the same thing you are writing. The only difference is in between this upper derivative and lower derivative. Here in this E alpha comma beta set, two real numbers are existing in between these two derivatives. That is the only difference. Okay, define first, you define a, and then what you have to define? You have to define E alpha comma beta like this. Same thing, but in between there are two real numbers existing, that is alpha and beta. Now after that, first you are proving a. This a is equal to this. This is what you are going to prove. What you are going to prove? A equal to this. A equal to E alpha comma beta. That is what we are proving actually. Okay. So here first to prove A equal to union E alpha comma beta. Okay. With union you write. Okay. Union alpha comma beta, this E alpha comma beta equal to, this equal to, two sets are equal. That is what you are going to prove. To prove that, what you will do, usually what you will do, A contained in this and this contained in A. This is what we prove, right, in normal. So like that you are doing now. First to prove A contained in union, write this. Now to prove this, what you will do, you will take an element from A and at the end you will say that same element is present in here. So if you say that, then this condition is satisfied. This is what the procedure you follow, right? So similarly here also you are taking an element from A, x belongs to this A, then x belongs to A, right? So this A, so that you can write this condition now. That is what in the next line you are writing. Then upper derivative f of x greater than lower derivative f of x. Now here you are having two values, right? Two values. So we know that between these two, surely there will be two rational numbers will exist. Okay, between two numbers there will be rational numbers existing. No, in a number line also, if you are having two numbers, means in between that two numbers, if you are having 2 and 3, in between these two numbers there will be rational numbers existing. Similarly here also you are having two derivatives. Between these two derivatives we can find rational numbers alpha and beta, such that you are writing like this. Now you know that this belongs to where? Here you are having this in where? In our this set you are having this. Okay, you got this now, so that you can write what? X belongs to this. No, you can write like this. No, so that is what you are writing, x belongs to this. And you know that E alpha comma beta contained in union E alpha comma beta, because this is union. So surely this E alpha comma beta will also present inside the union also, right? So that is why contained in union E alpha comma beta. So comparing these two, you are writing x belongs to this. So at first you took x belongs to A, and now you are having x belongs to this. So you can write what? A contained in union alpha comma beta E alpha comma beta. So this one condition is proved, and then you are going to prove this contained in this. Okay, so that is what you are proving. Same thing you are doing. You are taking x from here. You know that if you take x from here, means you will get what? This condition in the next line, right? So that is what, then you are writing this. So from this, combining these two, you are writing this. So you got this. This is the condition you are having in this set A, right? So you can write x belongs to A. So at first you took x belongs to this, and now you are having x belongs to A. So from this you can write what? This contained in this. So you proved these two conditions. So now what you can say? A equal to this, no? So therefore A equal to this you have proved. Now what we have to prove at the beginning itself, I am saying what you have to prove, m star of A equal to 0. Just above you have wrote A equal to union E alpha comma beta. So in the place of A you are putting E alpha comma beta. That is to prove m star of, ignore this union, okay? Just take this E alpha comma beta. M star of E alpha comma beta is in the place of A, you are substituting this value. Okay, to substitute this only, to substitute this, you are finding these things here. First to prove part is, for substituting in the place of A, you have to you are going to substitute this. For that purpose only, just above you have did A equal to, you have proved A equal to this condition. So m star of E alpha comma beta equal to 0. We have to prove this. So in the next page what you are doing is, let E alpha comma beta equal to E. Because in the further steps, if you write E alpha comma beta, E alpha, it is little bit confusing and looks not nice, right? So that is why in the place of E alpha comma beta, now onwards you are going to put E. Okay, that is why E alpha comma beta equal to E. Choose an open set. Now you are choosing an open set, that is O, and how you are choosing is this open E. You are having set E, no? This E means what? This E alpha comma beta. You are having that set. You defined it, right? So what you are saying is this E contained in O. This our set E, no, this E is present inside this open set O, and O present inside this what? Open interval A comma B. This is how choosing. You are choosing, and this condition also you are saying M star of A. When you take the outer measure of open set O, that will be equal to the measure of O, and this measure of O will be less than M star of E plus epsilon. This is how you are choosing. These things you have to keep in your mind without any confusions. Okay, what you have to do, you have to choose an open set, and what you are saying is you are having a set E, that E contained in O and O contained in open interval A comma B, and M star of when you take the outer measure of O, M star of O, that will be equal to M of O, and this M of O will be less than M star of E plus epsilon. Now you are taking another one collection, that is after taking open set you are taking a collection, that is script F. Now you are saying the script F is the collection of what? Closed bounded interval. What is this F? This F is a collection of closed, this is important. Since F is a closed bounded interval, you are going to bring vitally covering lemma here. Okay, so okay, let F is a collection of what? Closed bounded interval. Closed bounded interval, no, that is why you are taking closed interval, closed C comma D, and you are saying that this closed interval A comma B contained in where? Our open set O, for which this condition you are writing. This is also you are taking like that. First you are taking an open set and you are writing a story on that open set, right? And then you are taking a collection of closed bounded interval, and you are saying that this closed bounded interval contained in the open set O, for which this condition is also there. You are writing like this. F of D minus F of C less than beta of D minus C. So then, since F is a closed bounded interval, no, in the vitally covering lemma also you will have a collection F, and that collection F is a closed bounded interval. Here also you are having this F, and you are saying this F is a closed bounded interval. Therefore, you can say this F is what? Vitally covering of E. Vitally covering of whatever. Vitally covering of E. Okay, you told this F is vitally covering of E. Now you can use that lemma here. By vitally covering lemma, you are writing these two lines. There is a finite disjoint subcollection, this closed interval. You are having CD. Okay, you are writing here it with the suffix. That is the only difference. No, don't get any confusions. CK, there is a finite disjoint subcollection CK comma DK collection, no, so that is why K equal to, in the suffix you are having K, so that is why K equal to 1 to N of this F, for which M star of E difference union this less than epsilon. Okay, keep this in your mind. You are writing this by the definition of vitally covering lemma. M star of E difference union K equal to 1 to 1 EK comma DK. Okay, here you should not put CK, this is EK. EK comma DK less than epsilon. Union EK comma DK. Okay, E difference union EK comma DK. Don't forget this. Outer measure of this less than epsilon. Now we have, you are using this, okay, just writing the suffix you are putting K. The same line you are writing, but in the suffix you will put K and write F of dk minus F of ck less than beta of dk minus ck. Now what you are doing is you are taking summation I is equal to 1 to n on both sides. So here you are putting less than beta, summation 1 equal to summation k is equal to 1 to n, right? You are taking summation on both sides less than beta into, in the place of this, okay, the place of this you are putting measure of 0. Okay, measure of what? 0. Sorry, this is not 0, measure of O. I'm so sorry, what a blunder mistake it is. This is not 0, measure of O. Okay, what is this? Measure of summation k is equal to 1 to n dk minus ck. In the place of this, you are substituting what? Measure of O, because you know that closed interval, from this line you are writing that, okay, closed interval c comma d contained in O, right? So from this line I think they are writing this, okay, summation k is equal to 1 to n dk minus ck beta into m of O. This is equal to the measure of O. So that is what we are writing. This is less than beta. In the place of measure of O, you can put what? Substitute this value, no? Less than this value, no? That is why here I am putting less than beta of m star of E plus epsilon. So here, here also you are putting a less than, right? The reason is because this interval is present inside this O. That is why less than, okay? Less than beta of. Can you understand this? Now you are having a lemma. This you are from a lemma you are writing this result. We have memorize it. M star of E intersection ck comma dk less than or equal to 1 by alpha f of dk minus f of ck. I will tell you, is there any short trick to keep this in your mind? E intersection ck comma dk. Okay, so you are taking m star of E intersection this ck comma dk. Okay, m star of E intersection ck comma dk less than or equal to 1 by alpha f of this f of dk comma f of dk minus f of ck. Is that clear? First put m star and then what you put? M star of E intersection, write this value, copy it, close the bracket, then less than or equal to 1 by alpha, open this square bracket and write this value, okay? This will help you to stop memorizing these things. What do you have to do first? First put m star and then m star of E intersection, write this value, then close the bracket, less than or equal to 1 by alpha, then open the square bracket and write this, copy it. Is that clear? Now here is no need to memorize anything, right? We have to write this also. E is the subset of, that is E contained in this. That is, don't worry, just copy this. But write it with the union, okay? We have these results, okay? That is what you are writing it again and again. Okay, so we have to keep these things in your mind. There is no another way. There is no any other easy way than this. Okay, so we have E contained in put this intersection of the same thing you are writing, but with the union k equal to 1 to n. Okay, you are writing another one bracket will also come. Sorry, one bracket. Okay, what is this? E contained in E intersection of union k equal to 1 to n, the ck comma dk. Okay, then union E minus the same value, right? No difficulty in writing this. Please concentrate. First you write E contained in, then E intersection union of this value, then union, okay, then E minus union of the same value. Here you are having intersection, here you are having minus. That is the only difference between these two terms. Don't confuse in writing intersection, union, minus, okay? So be clear in where you are putting intersection, where you are putting minus, and where you are having union. Okay, otherwise you will be putting here union, or you will mix everything. Okay, to stop doing that, you must focus on where you put what you have to put there. You have to be clear in that. So E contained in E, put this E intersection, then union this value, then again union E minus the same value. Is that clear? Now taking measure, if you completed till this, then the steps comes after this will be very easy. Okay, then taking m star on both sides, m star of E less than or equal to m star of this value, copy it, no difficulties, union, no, so plus m star of this value. Now less than or equal to, already you are having E minus this value is what? M star of E minus union ck comma dk. I think in the place I mistakenly write ek. This here you have to write ck. Okay, what a blunder mistake, you know. ck. If the here you are having ck means, then it is very easy to you to keep this in the mind, right? It's a blunder mistake. Please correct it. I'm so sorry. Okay, mistakes are common, right? But only thing we have to correct it. So I corrected it, so there is no issue. Okay, m star of E minus union. Okay, in the place of this you are substituting epsilon because you are having this value is less than epsilon, no? So just substituting in the place of this I am putting epsilon. So here write this term as it is. Okay, then less than or equal to, write this term, and in the place of m star of E intersection this, you are substituting this value. Okay, substitute that, and then less than or equal to 1, bring this 1 by alpha outside this, so the outside this summation, so 1 by alpha summation k is equal to 1 to n f of dk minus f of ck plus epsilon 1 by alpha, in the place of summation k is equal to 1 to n f of dk minus f of ck, you are substituting what? Beta into m star of E plus, that is, wait a minute, you are having the value, okay, f of d sum, here you are having, wait, here there is a confusion, f of dk, yeah, less than beta of, yeah, I'm so sorry, what a big confusion. You are substituting the value of this, okay, the value of this is what? This, no, so I'm substituting in the place of this, I'm substituting that value. Okay, so 1 by alpha into beta of this value, because the value, this value you are having here, right? The place of this I'm substituting this value. Just substitute it plus epsilon, that is equal to, when you do multiplication all these things, you will get beta by alpha m star of E plus beta, when you multiply these two you will get beta by alpha m star of E, and then you